expressing particular data values. Now remember, the middle, what always goes in the middle when we have a normal curve? You guys remember? Mu, mean. So we're just going to put mu. It's like a U, or smaller. Okay, mu. This would be right here, mu plus 1 standard deviation. Do you guys remember the variable for standard deviation? It's a variable for standard deviation that we always use. It's another Greek letter, not mu, but what? Sigma. So this is mu plus sigma. This is 1 standard deviation above right here. This one is 2 standard deviations above, so to get to there, I have to go mu plus 2 sigma, right? 2 standard deviations. And here would be mu plus 3 sigma, 3 standard deviations. Here would be 1 standard deviation below, mu minus 1 standard deviation, mu minus 2 standard deviations, and mu minus 3 standard deviations. I'll fix my mu here. Mu. Gotta get used to saying that. Mu. All right. Look at the first standard deviation. Remember, it's the point where the curve changes direction. It's always the first one, and it's your second, third. No, it's just the same distance. Okay, now on your notes, go to write x represents a data value. X represents a data value. Now remember, a normal curve is representing data. And what if I wanted to express a data value within all this data value, one particular x value, or one specific data value? Let's allow it to be expressed by x. So if I said, what if a data value is in this region here? Go ahead and shade that in. Yes. That's what you said? Oh, of course. Go ahead. What if a data value x was in that region? Go ahead and shade that in for me. So right now, let's pretend that all the data represents Park West students' ages. I want to zoom in on Ms. Rodriguez. She'll represent x right now. She's a specific data value within all the data. This is all the data values here, this curve. Everything underneath the curve is all the data of Park West. I want to zoom in and focus in on one specific student. Let's allow that student to be x. It's a data value, namely Ms. Rodriguez, if you don't mind. And let's say Ms. Rodriguez her height is below average, but above the first standard deviation below the mean. In other words, what if Ms. Rodriguez, her data value is in between? In this region that I shaded, she's somewhere in there, like other students. How would I express her height? Here's how to express it. Ready? If I want to express a data value in this region of the data, I'll write this. Ready? With x is greater than or equal to mu minus sigma. Look at that's the first standard deviation below, but it's also less than or equal to mu. This represents Ms. Rodriguez. because her data value is in between. Look, it's greater than this data value. Look, that's one standard deviation below. Like it's greater than or equal to it, but it's also less than or equal to the mean. Like so this X describes everything that's shaded. So the X is found in the shaded region, and notice the greater than or equal to, so greater than is that way, less than is this way. So this data value, namely Ms. Rodriguez, is greater than or equal to the standard deviation below, that's this value, look at this one I put here, but less than or equal to the mean, that's mu. So that describes the region. Let's try another one. That'd be example 1. Go to draw another curve. Again, the more you draw them, the quicker you're going to get. Standard deviation, or actually the mean, standard deviation, 2 standard deviations, 3, 1, 2, 3. How would I describe a specific X value in this region now? How would I describe X? Let's see. Well, this is mu. This is mu plus standard deviation. This is mu plus 2 standard deviations, 2 sigma. And this is mu plus 3 sigma. So if I want to describe an X value in that region, it's going to be X is greater or equal to, what's the left side boundary? It's right here. Mu plus 2 sigma. Less than or equal to the right side boundary, mu plus 3 sigma. I need to practice writing my mu's. There we go. So this inequality symbol describes the data value that's found in that territory of the data, that region of the data. Now, since you don't have colors on your, you either have a pen or pencil, and you can't color code, just put an arrow from this region to this statement here. Because I'm going to color code now. I'm going to color a different region with blue. Not this region. How would I describe a data value in this region? Okay, so give me the statement of a data value in that region, Miss Rodriguez. Looks like you're already thinking. So say this is mu and that's sigma. So I would say.
Mu minus 2 sigma.
Nice. That's the left boundary. Look at 1 sigma, 2 sigma.
Greater than or equal to.
X is greater than or equal to that.
And then next one is m.
Less than or equal to.
M mu sigma.
Mu
Okay.
minus sigma. Here we are. Look at the left boundary. Look at the left boundary. That's mu minus 2 sigma. Look at 2 sigmas. The mean minus 2 sigmas. Mean minus 2 sigma. Boom. The right boundary of the territory is mu minus 1 sigma. And X is in between them. So X is found anywhere in here. X is in that region or territory. Someone besides Miss Rodriguez do the red for an extra stamp. Who can tell me the red? The X, describing X in the red territory. Someone besides Rodriguez. It's always going to be X is greater than or equal to something and something. For extra stamp. The red. Juarez, Ortiz, Pinello, Castro, or Austin? Okay, describe the red. Let's sit my coffee. Left boundary goes on the left, right boundary goes on the right. So look at the left boundary and the right boundary. That's the left boundary. Done. Easy. Once you get the hang of it, it's not a big deal. This is about boundaries. Okay? Last one, you're going to do on your own. Raise your hand when you got it, and I check it, and then go grab your Chromebook and do the empirical rule video on your own. For those of you who were absent yesterday, Ortiz and Pinello, you don't have to do that. You can just go write your assignments. But try this one first on your own. I'm going to highlight this one in black. Describe this one and raise your hand. Most of us will watch the video shortly in a second here. Well, you're going to be in the video now. We just spoke. Watch this. So the rest of you, give me the X, describe this region and the X value in that region, please. And then raise your hand.